Proper mounting, balancing, and installation are absolutely crucial to achieving a smooth, comfortable ride, vehicle control, and may help extend the life of your tires. Tire wheel assemblies that are out of balance can cause vehicle vibration and irregular tire wear, leading to driver discomfort and early tire removal. Once you have mounted and inflated a tire, you should balance the assembly for optimal vehicle performance at highway speeds. An out-of-balance assembly can create a vibration that will get worse as the vehicle's speed increases. Goodyear recommends balancing all assemblies in the steer position. Proper balance helps to minimize objectionable irregular tire wear. If a vibration is felt in the steering wheel, it's likely the affected assembly is on the steer axle. Balancing allows the assembly to spin without causing any vibrations. This can be done by a balancing machine checking for heavy spots on the assembly. When the balancer locates a heavy spot, a weight is placed on the opposite side of the wheel from where the heavy spot is located. No matter how carefully assemblies are initially balanced, they can eventually lose their balance. Over time, as the tread wears, the distribution of weight can change, altering the balance requirements. There are two types of imbalance that can affect a tire wheel assembly: static and dynamic. Dynamic balance takes into account balance in two planes, while static balance takes into account only a single plane. If an assembly has a static imbalance, the assembly will bounce. Appropriately sized weights will bring the assembly into static balance. The standard practice is to put half the weights on one side of the wheel and half the weights exactly opposite on the other side of the wheel. If an assembly is statically balanced, it may still have a dynamic imbalance. Dynamic imbalance causes the assembly to wobble and hop. A dynamic balancing machine determines the size and exact location of each weight on both rim flanges of the assembly. Dynamic balance is the most common method used today. If an assembly is dynamically balanced, it is also in static balance. Assemblies can be balanced either on vehicle or off vehicle. Off-vehicle balancers are more common and generally more accurate than on-vehicle balancers. An off-vehicle balance is the best choice because balance is not affected when it comes time to rotate the tires. Most off-vehicle balancers can perform dynamic as well as static balance. Before you begin balancing the assemblies, clean any flat tire sealants or water from inside the tire. Remove all old wheel weights. Clean deposits of foreign materials from the inside of the tire wheel assembly, and make sure there are no stones in the tread. Check each tire for the correct tire pressure. The shop must have an up-to-date and accurately calibrated computer spin balance machine, which should be professionally operated and capable of achieving both static and dynamic balance. For a procedure to check the accuracy of your balance machine, see our video, Wheel Balancer Repeatability Check. The balance machine will measure the assembly's fluctuations in weight by simulating vehicle operation. This is the best way to ensure proper balance of the assembly. The tire wheel assembly on the balancer needs to be mounted in the same way it is mounted on the vehicle, whether the pilot is hole-centric or lug-centric. It is absolutely necessary to center the assembly on the balance shaft. If it is not centered, the results will not be accurate. Securely mount the tire wheel assembly on the balance machine. Begin to prepare the machine for operation by entering the required information about the tire and wheel. Follow the manufacturer's operating instructions step by step. After spinning the tire wheel assembly at a predetermined speed, the balance machine will indicate the correct amount of weight to use and where to place each weight. Externally applied balance weights have been around for many years, but they are no longer the only option for tire wheel balancing. Some fleets prefer internal balancing materials. These dry polymer products can be put into the tire when mounting it on the wheel. Once inside the tire, the material is free to distribute around the inside of the tire, responding to force variations as the assembly rotates. These force variations are the result of imbalance in the assembly. Goodyear does not endorse any particular brand, material, or method used to correct the balance of a tire wheel assembly. If a vibration persists after the tire wheel assemblies have been properly balanced, the vibration is most likely coming from the imbalance of another vehicle component or run out with one or more tire wheel combination. An experienced balance technician will look for signs of run out when the tire is being spun up during the dynamic balance correction procedure. For tips and techniques on eliminating run out, check out our video on recommended practices for correcting vehicle run out. Out-of-balance assemblies will cause the vehicle to vibrate at certain highway speeds. Balance-related vibrations are receiving more attention as fleets are trying to improve driver comfort and welfare. If you have any questions concerning the materials discussed or would like further information on balancing assemblies, contact your local Goodyear commercial tire dealer or go to our website for additional information and suggestions.